Hey guys, this is the last lecture of Unit 1. So we're going to talk about how to use operation and order symbols to write mathematical sentences. So you'll get a phrase or a sentence in English, and we'll try to represent it with numbers, letters, and operations. And when we say operations, operation symbols are just plus, minus, I almost said add, multiply, divide. You could say like raising something to a power is an operation. And then we're going to identify identities and inverses. That will make more sense when you see them. Inverse just means an opposite. But we're going to look at a few identities that are just rules for math. Use the commutative, associative, and distributive properties, write algebraic expressions. So algebraic expressions are mathematical sentences written with algebra. And then we're going to simplify those expressions. Okay, it sounds like a lot. It is a lot, but I think you will understand it. If you don't understand it, just send an email. All right, algebraic expressions, an expression is different from an equation. So an equation is a statement that two expressions have equal value. So you see in the definition of equation, we have the word expression. So this was expression, we're writing algebraic expressions, and we're simplifying algebraic expressions. And if you look ahead to even our very last slide, what you're going to see is that there are no equal signs. So if there are no equal signs, it's simply an expression. It's expressing algebra. However, if you have an equal sign, it becomes an equation. So an equation is telling you that something is equal to something else. So an equation will have an equal sign. An expression will not have an equal sign. So in English, we could substitute the equal sign with the phrase equals, the words equals, gives, is, was, should be, yields, which is just another way to say gives, amounts to, represents, or is the same as, okay? And all of this is building up to solving. So after simplifying algebraic expressions, what we will do is, not today, but what we are leading up to is solving algebraic expressions. Oh, sorry, equations. You can't solve an expression. There's just a little lesson in the difference. You cannot solve an expression, you can solve an equation. What you can do with an expression is you can substitute an amount for one of the variables, but an equation you can find what the variable is equal to. All right. Oops. Two-sided. For example 1, write each sentence as an equation. Okay, so we have the difference of 7 and a number is equal to 42. Again, if you know this, you don't need to take exactly the notes I take. The difference of 7 and a number is equal to. So I just want to break down the parts of this. And I kind of jumped ahead and said that the difference is minus. So when we are subtracting, we are taking the difference between two numbers, right? Because right here, if I had a number line, I'm going to be drawing a few number lines. So if I had 7 is here and 10 is here, and I said, what is the difference? I'm going to say the difference is 3, right? So that's the same as subtracting 10 minus 7 is 3. So the difference is subtraction. Sorry, should have asked you what you thought it meant first. But basically the difference is minus, and then we have 7 and a number. A number is whatever letter you want it to be. So it's algebra. We're replacing what we don't know, right? We don't know this amount, so we're replacing it with a letter. That's kind of the definition of algebra. Is equal to, like we saw on the last slide, we know that that is the equal sign, and then we just have the number 42. So we have written this English sentence as a math equation. 7 minus x equals 42. So this is not an expression because it has an equal sign. Because it's an equation, we can solve it for x. If it was an expression, it would just say 7 minus x. All right, here we have the quotient of, and I think I'm just going to tell you again, quotient means the answer to a division problem. The quotient is the answer to the division problem. So the quotient of, we have y and twice x is the same as, ooh, so many. The product of 4 and z. The product is the number you get when you multiply. So the quotient of y and twice x, right? Twice means 2. It actually means 2 times. So I'm going to put the 2 right next to the x, or I could put it with parentheses around the x to show that we're multiplying the 2 times the x is the same as the product of 4 and z. Okay. There is another way to write this. You can make that division. This is a horizontal division problem. You could write it vertically. Y divided by 2x is 4z. Okay, that's not more correct. Neither one is more correct. Those are just 2 different ways to write that sentence. Good. Okay. So those were equations. That means they had equal signs. Equality and inequality symbols. Okay. So A is equal to B. When we're using inequality symbols, one might not be equal to the other, but we have a sign that will tell us something about the relationship between them, right? Maybe B is smaller than A. Maybe A is smaller than B. So here we have A is not equal to B. Here we have A is less than B. Here we have A is greater than B. Here we have now 2 options. A is less than B, or A is equal to B, right? And here it will be A is greater than B, or A is equal to B. And just there, like in earlier courses, you may have learned like about, I learned an alligator. The alligator eats the bigger number, so A is bigger, or it's an arrow and it's pointing towards the smaller number. However, it would be best to just memorize that, because we always read it from left to right. So always memorize that this sign means less than, is greater than, is less than or equal to, is greater than or equal to, so that you're always reading it correctly. Okay. Now we are going to insert the less than or greater than symbol between the following pairs of numbers to make a true statement. I'm going to ask you to do it yourself, okay? But first we can draw a number line, because if you struggle at all with greater than and less than, try picturing a number line in your head. It might help. 1, 2. Need to get to 9. Don't care as much over here. All right. So try these on your own. Pause the video. See if you put whatever you want. And then play and see if I have the same ones as you. Okay. So -6 and 6. I'm going to say -6 is less than 6, and that's how I would write that. For B, I would say 5 is greater than -9. Okay. Maybe some more information about the number line. 0 is neutral. That means it's neither positive nor negative. Everything to the right of 0 is positive. Positive is to the right. And any number to the right of another number is larger. Larger to the right. And it doesn't matter if you're at 0 or if you're at a different number. It's always larger numbers are to the right. Negative is to the left of 0. And you will always get smaller to the left. Zero is neutral. Should make that more clear. 0 is neutral. And then we have negative to the left, or smaller numbers to the left, positive numbers to the right, larger numbers to the right. Okay, so we have -6 is less than 6. 5 is greater than -9. -12 is what to -8, okay? Because it's clear always when we're working with positives that larger goes to the right, right? If this was +12 and +8, we would know +12 is greater than +8. But if you look at negative numbers, and we truly believe that it's smaller to the left, -12 is going to be down here, and that's smaller. So we're going to say -12 is less than -8. Here, I'm going to show you where these are on the number line. -2.7. So here's -2.7. If I broke this into 10, I think 7 would be about here. So I'm going to call this -2.7. And -2.1 is going to be very close to -2. Which one is, or sorry, -2.7 is smaller or larger? It is smaller. So that means less than. -2.7 is less than -2.1. Okay. 8.25 and 8.250. Let's find that on the number line. Here, 0.25 is like a quarter, right? 25 cents. So we just break this into 4. And we say this one is 8.25. Where would 8.250 be? It's in the exact same place. Because these are behind the decimal, you can add as many zeros as you want, and it does not change the value of that number. Just like if I put a 0 in front of the 8, it does not change the value of the 8. Good? So those are equal. 0 and -7.8. So, -7/8. -7/8 8/8 would be 1 whole. So negative 8/8 would be -1. So negative 7/8 is close to negative 8/8. It would be right about there. I don't have enough space to write it. That would be negative 7/8. And that is less than 0. So we say 0 is greater than negative 7/8. Okay. So remember, if you're struggling with greater than or less than, visualize the number line. It might help you. Remember, anything to the right is larger, anything to the left is less. Now we are going to translate each sentence into a mathematical statement. And now we are practicing doing it without an equal sign. Okay. I mean, we might have less than or equal to or greater than or equal to, but we won't be using just plain equal sign. The difference of, we remember that from earlier, we know that that is minus. The difference of 7 and x is less than or equal to 21. Less than or equal to, and then we have 21, 7, and x. Okay. The difference between 7 and a number is less than or equal to 21. Next, we have is not equal to, and that was just the equal sign with a line through it. And then we know plus, right? 9 is not equal to x plus y. Here we have is greater than. We also have the sum of. The sum of goes with this and, because we're taking the sum of two numbers, okay? And sum of is to add. And then finally, down here we have squared, like x squared. So the squared is going to be up here. Ooh, sorry, is greater than. 30 is greater than the sum of 9 and x squared. All right, the identity property, this is the one these are properties of real numbers. Remember, real numbers are any number you can imagine on the number line. And in the very first let's just throw it somewhere. No, here it is. All right, so our very first slide, I said identifying identities and inverses. So now here's where the identities come in. This is the identity property. So when you think identity, it's like my ID card or something, right? So your identity is yourself, or I would say its identity is itself, okay? My identity is who I am. So the identity property, this is called the additive identity property. And then we also have a multiplicative identity property. And what these are saying, if you look at it, 0 plus a equals a, 1 times a equals a. What are they trying to tell us? Itself, its identity does not change. So the identity property is telling you anything plus 0 is itself, it remains itself, and anything times 1 is itself. That's all those identities are saying. Those properties are saying, okay? The opposite property means that a and negative a are the same distance on the opposite sides of 0 on the number line, right? Another number line. So here's 0. Here's +3. Here's -3. So what I'm saying is, use a different color. -3 plus 3 is 0 because 3 and -3 are both 3 units away from 0. So they're the same distance away on opposite ends, so they will always add up to 0. That's the opposite property. The reciprocal property, to reciprocate means to flip. So to flip, if I take A and then turn it into a fraction and flip it, I will always get 1 when I multiply those two terms. So here I said I take the value that is the same distance from 0 on the opposite side of the number line. Here I'm going to take my original number, I'm going to flip it across the fraction bar, multiply it by that, and get 1. Okay? So if I ask, what is the reciprocal of the number 2? I want to make the reciprocal of 2. What I need to do is I need to turn 2 into a fraction. How do I turn any number into a fraction? I divide it by 1, right? 2 divided by 1 is still 2. So the reciprocal of 2 is, I flip it. I put the 1 up here. I put the 2 down here. This is the reciprocal. 1/2 is the reciprocal of 2. If I multiply them together, I should get the number 1. 2 times 1/2 is 1. Or I could say 2 over 1 times 1 over 2 is 1. All right. The double negative property, we've already seen it in this course, but it's basically if you subtract a negative number, it's the same as adding that number. It becomes a positive. Subtracting a negative number makes that number a positive. All right. The commutative property is just telling us that you can move it only. These two only apply to adding or multiplying, okay? These only apply to adding or multiplying. They do not apply to dividing or subtracting. But according to the commutative property, you can switch the order of numbers and get the same answer, right? And we can even do a little proof. A plus B equals B plus A, because 1 plus 2 equals 2 plus 1. Right? That's the commutative property. They're moving around. Like you commute. Well, you don't commute to school, right? Because we're on video now. You can move things around. 1 times 2 is still equal to 2 times 1. That would be the commutative property. Associative property, I think of it as like who you associate with, or who you are familiar with, or who you are friends with. To me, it looks like groups of friends, right? So my friends are, A and B are friends, and then they add C, and then B and C are friends, and then they add A. So again, we'll just do 1 plus 2 plus 3, and then 1 plus 2 and 3. Good. And they just want you to see that these will still be this, you'll get the same answer, even though you're going in a different order. So here we have to say 1 plus 2 is 3, 3 plus 3 is 6. Here we have to say 2 plus 3 is 5, 5 plus 1 is 6. Good? All right. Distributive property, or did you want to see the multiplicative associative property? That would just be 1 times 2 times 3, and then 1 times 2 times 3. So 1 times 2 is 2, 2 times 3 is 6, 2 times 3 is 6, 6 times 1 is 6. All right, for the distributive property, This is what we're going to be using all the time. So make sure you feel really good about the distributive property. The distributive property says whatever is outside the parentheses, but multiplied by it, has to be multiplied by everything inside the parentheses, okay? So these are being multiplied because they're right next to each other. So I have to say A times B and A times C. So A times the quantity B plus C equals A times B plus A times C, okay? All right. For example 4, we're just doing the opposite. Another word for opposite is additive inverse. So these are the same. We want the additive inverse of each number. And again, the additive inverse is just the opposite distance from 0 on the number line. Same distance from 0 on the number line in the opposite direction. So the additive inverse of 9 is -9 because 9 plus -9 is 0. The additive inverse of -1/8 is +1/8 because -1/8 plus 1/8 equals 0. The additive inverse of 0 is 0 because they are 0 units away from 0 on the number line. Now they want us to find the reciprocal, which is the multiplicative inverse. The multiplicative inverse is the reciprocal. We saw it here. So we're going to flip it and make sure the answer is 1 when I multiply it with its reciprocal. So the reciprocal of 11 is, right? So what I needed to do was I needed to turn it into a fraction. 11 as a fraction is 11 over 1. So the multiplicative inverse is 1 over 11. These are the same. The reciprocal is the multiplicative inverse, right? If it is not a fraction, I make it into a fraction. If it is a fraction, I flip the fraction. Okay, so let's check these. 11 times 1/11 is 1. And you can kind of see it, right? Because 11 over 1 times 1 over 11. If we're multiplying fractions, we just go straight across. 11 times 1 is 11. 1 times 11 is 11. Good. 8 over 3 times 3 over 8 is 24 over 24, which is 1. Good. -7. I keep it negative, okay? Because we're not doing distances on the number line. We're not adding and subtracting. We're only multiplying. So -7 needs to be multiplied by -1/7 to get 1. Because if I said it was +1/7, -7 times 1/7, I would get a -1. So I have to make sure my reciprocal remains negative. Okay. Now use the commutative or associative property to complete. And remember, commute just means move. So we're going to move them around if there are only 2. If there are 3, we could do the associative property or the commutative, really. But it already has parentheses. So if you have parentheses, the associative property just says B should leave A and go to C. All right, so commute. We're just going to go from x plus 8 backwards, 8 plus x, okay? 7 times x to x times 7. Good. Now we're doing associative property. 8 doesn't want to associate with 1 anymore. It wants to associate with 3. So now we have 3 plus 8 plus 1. Negative 5 times 4 times 2 now becomes negative 5 times the quantity 4 times 2. And you could also write it as just negative 5 parentheses 4 times 2. Just make sure you keep the parentheses because it has to, we have to do these first. All right, x times y times 18 becomes x times 18y. What do you think of that? Or x times y times 18. Neither answer is more correct than the other. And again, these were commutative, the commutative property, and these were the associative property. These will not be used as often as the distributive property. So the one we want to really get a handle on is the distributive property, okay? So we're going to multiply using the distributive property. If you have anything being multiplied by a set of parentheses, to solve it, you must multiply the term outside the parentheses with each term inside the parentheses, okay? So we're going to say 7 times x. 7 times x is 7x. 7 times, and make sure you keep the sign, a positive 4y is, 7 times 4 is 28, so it'll be 28y. So that's a positive and a positive, so we're just going to say it becomes 7x plus 28y, okay? Next one, 3 times a negative 5 is a negative 15. 3 times a positive 9z. 3 times 9 is 27. It's a positive, so I'm going to say plus. And then z just comes along with it. All right, for letter C, is there in fact a number to distribute here? Is there something to distribute here? Yes, there's a negative sign to distribute, and the easiest way to distribute that negative sign is to realize that it's a negative 1. So what they're actually asking us to distribute is negative 1 to an 8, an x, and a negative y. Or sorry, a negative w. Okay? So negative 1 times 8 is negative 8. Negative 1 times a positive x is a negative x. And then a negative 1 times a positive w, no, sorry, a negative 1 times a negative w becomes a positive w. Good. I'm multiplying by 1, but I don't need to say that that's 1x and 1w. It's understood. If there's no number in front of it, it's 1. Now we're going to practice writing the sentences as an algebraic expression again. These are a bit more complicated. We have to think about what it's saying and how to express that, like what math. I end up doing math in my head, and I have to think about what math I'm doing and how I would write it, okay? So when you think of what the answer is, when you put an example like 1 or 2, you have to think about how you got that answer. How did I get that answer? Oh, I multiplied everything by 10. Oh, I added a. Oh, I subtracted from 180, okay? So this says a vending machine contains X quarters. That's the amount of quarters. Write an expression for the value of the quarters. So 1 quarter's value is 25 cents, right? A vending machine contains a mysterious unknown amount of quarters. What expression could we write? Like these are expressions. What expression could we write for the value of the quarters? So ask yourself, if it had 2 quarters, what would the value be? The value would be 50 cents, right? So if I had 2 quarters, it would be 50 cents, right? How did I get that? I multiplied 2 times what? 25, right? So if I had 0.25 times 2 equals 50, right? What if I had 10 quarters? What would the value be? $2.50, right? I'm going to add that 0 because we're talking about money, and it wouldn't change the value of the decimal, right? So 10 quarters in the machine would give me $2.50. So what expression can I write? 1 quarter in the machine would give me 25 cents, right? So the thing that's changing is the 2, the 10, and the 1, the amount, right? And so that would be our x. And then we're taking that x and we're multiplying it by what? By 25. So x times 0.25. And it's an expression, right? So we don't even need an equal sign. Or you could just say 0.25x. Neither answer is more correct, okay? So now with this, I can know the value of the entire contents of the vending machine if you just tell me how many quarters. You tell me how many quarters, I can tell you the value. The cost of Y tables if each table costs $230. The cost of Y tables if each table costs $230. So if I had 1 table, right? 1 table, I would cost $230. If I had 2 tables, it would cost $460, right? If I had 3 tables, it would cost $690. So what expression can I write to represent that? Here we had 2 times 0.25 equals 0.5. 2 times t equals 460, right? Is that the equation I want to write? The cost of Y tables. Y is the amount of tables. So Y is actually the 1, 2, 3. Y tables, and I multiplied it by something, right? What did I multiply that Y by? I multiplied 1 times what to get 230? 230. So no matter how many tables, if I want 10 tables, I'm going to multiply that by 230, and that will give me the cost of 10 tables. Good. And again, or we could just say 230y. C and D. 2 numbers have a sum of, and remember sum means plus. 2 numbers have a sum of 40. One number is A. Represent the other number as an expression in A. So instead of saying B, I'm going to say it's A something. Okay? Think about this. If A is 10, how much is this number? If A is 10, how much is this one? This one's going to be 30, right? How did we know? If A is 5, how much is this going to be? 35, right? How did we know? We subtracted A from 40. A minus 40 will give me the other number, right? A minus 40 plus A is 40. So if A is 15 plus 15, sorry, 40 minus A would be a negative. 40 minus A. 15, 40 minus 15 is 40. 5 plus 40 minus 5 is 40. So to represent the other number as an expression in A, we would say 40 minus A is the other number plus A. And because it's an expression, we don't need the equals 40. Good. 40 minus A plus A. So what if A is 39? 40 minus 39 plus 39. 40. Minus negative 10 plus negative 10. 40. All right. Two angles are supplementary. This is geometry. Don't worry about the geometry part of it. This is 180 degrees. A straight line is 180 degrees. A complete circle is 360. Half of 360 is 180. All right, and two angles are supplementary if the sum of their measures is 180. So this would be the measure of angle X. And then this would be the other angle. If the measure of one angle is X degrees, represent the other angle as an expression in X. So we want it to equal 180, right? Two angles are supplementary if the sum, if when we add them, it's 180. If the measure of one is X, represent the other angle as an expression in X. So it'll be just like this one, right? If this is X, we find this by subtracting X from 180. So the algebraic expression I'm going to write is 180 minus X plus X. Terms are just numbers and variables, all right? Like terms contain the same variables raised to the same powers. So I'm going to write 3x minus 5 plus 7y plus 2 minus 8x plus 4y. Good. These are only raised to the first power, right? But down here, we'll have some raised to the second power. All right, if you were to just split this polynomial at each addition or subtraction sign, that would give you terms. So this has six terms, okay? Each piece is a term. Like terms will have the same variables raised to the same powers. So if I was to say those two are like terms, 3x, now I can combine them, 3x minus 8x. That's just saying 3 minus 8, and then I'll add the x in. 3 minus 8 is negative 5. Good? So I had 3 x's, and then I subtracted 8 x's. Now I have negative 5 x's. $7y and 4y, I'm going to get 11y. And we tend to write in the order of highest power to lowest power. So this is x to the first, y to the first, and these are to they have no variables, so they always go at the end, and we call them constants. -5 and +2 is a -3. Good. So if I took this polynomial of 6 terms and I combined the like terms, I would end up with 3 terms. Okay. All right, so here to simplify, we're just going to combine like terms. Okay, so first underline the terms and then combine them. Good. Let's see. Here we have 3x. Always take the sign in front of it. So remember, I separated each term before the sign. So this is a -5. 3x minus 5x is a -2x. And then the 7 does not combine with any. That's as simple as I can make it. That's as much as I can simplify it. Pause the video, try this one, see if you get what I get, okay? (8x plus 10x is 18x. (-8 minus 3 is a -11. So I got 18x minus 11 here. (-7x plus 3x is -4x. +5 minus 2 is +3. That's as simple as I can make it. Here I have 3 like terms. 3 minus 2 is 1 plus, that's an understood 1, right? That's 1y at the end. So 3 minus 2 is 1, plus 1 is 2y. And then -5 minus 7 is going to be a -12. So I have 2y minus 12. All right, for these two, we need to distribute before we simplify, okay? Because combining like terms is actually adding and subtracting. And if you look at PEMDAS, right? It says to add and subtract at the end, and parentheses are at the top. So we're going to do the distributing first. 7x squared plus 3 minus, and so now it's a -5. I'm multiplying by everything. So I shouldn't have even written that minus. I should have checked. -5 times x squared is a -5x squared. -5 times a -4 is a +20. Good. All right, now let's combine like terms. So we have 7x squared and -5x squared is 2x squared. And then I have a +3 and a +20, so it'll be plus 23. Good. All right, here we're distributing a fraction. But if you think about it, 1/2 is just 1 divided by 2 times 4, okay? So 1 divided by 2 times 4. If I look at that, if I look at 1 divided by 2 times 4, my answer is 2, right? 1 divided by 2 times 4, and if I want to change the 4 into a fraction, I put it over 1. So that's like saying 1 times 4 is 4, 2 times 1 is 2. So if you ever are multiplying by a fraction with 1 on the top, you can also just take it as divide that number by the bottom of the fraction, as long as the top of the fraction is 1, right? Because I'm multiplying 4 times 1 divided by 2. 4 times the top of the fraction divided by the bottom of the fraction. So I'm just going to write it as fractions, and then we'll simplify those fractions. So basically 1/2 times 4 becomes 4/2. A. -6 times 1/2 becomes -6/2b. So I'm going to come back and I'm going to divide 4 by 2. And I'm going to divide -6 by 2. -1/3 times 9a is -9/3 a, minus, because it's a -1/3, 12/3 b. -1/3 times a -1 is a +1/3 +1/4. Okay? And I can see 4 divided by 2 becomes 2a. 6 divided by 2 becomes 3b. 9 divided by 3 becomes 3a. 12 divided by 3 is 4b. +1/3 +1/4. Those are a bit more difficult, right? All right, so we have, I'm just going to leave that there for now. 1/3 +1/4. Again, when we had the pizzas, okay, that's divided into thirds. That one's divided into fourths, right? We have 1/3 and we have 1/4. Good? But I can't combine 1/3 and 1/4 evenly, right? So I need to think of what can I split this into as smaller pieces? How can I split this into smaller pieces? What can I divide? What can I multiply both 3 by something and get what number can I divide by 3 and divide by 4, right? And the quickest way to do that is just multiply that one by that one, multiply that one by that one, right? So now every 4 piece is multiplied by 3. Every 3 piece is multiplied by 4. 1, 2, 3, 4. Good. So now I have 1, 2, 3, 4 pieces here out of 12. And here I have 3 pieces out of 12 here instead of 1 out of 3 and 1 out of 4. So I multiplied both the top and the bottom by 4, and I multiplied both the top and the bottom by 3. So then that becomes 4 times 1 is 4. 4 times 3 is 12, plus 3 times 1 is 3. 3 times 4 is 12. So I get 7 twelfths. Here I got 7 twelfths. Okay. Or remember Mr. Smiley, 1/3 plus 1/4. Start up here. 1 times 4 is 4. 1 times 3 is 3. 4 times 3 is 12. Either way. Okay, so now 1/3 and 1/4 I can call 7 twelfths. Okay, now we just combine like terms. So I have a 2a and a -3a. That becomes a -a. And then I have a -3b and a -4b, which will be a -7b. And then I just add the 7 twelfths. All right, and that's all I have for you guys today. Your exam is the next, so these assignments will be due midnight before the exam, and make sure you take the exam between 8:30 and 4:30 on the day of the exam, and then we will start unit 2 after that.